p to the power 440 plus 1 minus 9p upon 10 to the power 60.
Okay, so from there you have calculated p hat as 0.97. If your calculation is wrong, then p hat will be 0.97, and then you need to find the value of test statistic when you are testing the goodness of it, right?
Yes, sir.
So how do you calculate those? How do you test for goodness of it? Goodness of it?
So I have multiplied it by 600 and divided it by
600 or 500? How many these are?
so it is total 446 500.
500, right?
Yes,
440
sir.
and 60.
Yes, sir.
Okay.
So
So how
sorry, I am getting. Oh, sorry, I have taken the 600. That's why I am getting the wrong answer.
okay.
Sorry. So and one more question in the activity question 11.10. So
Okay. Okay.
sorry, sir. In the lecture 11.10, sir have taken the beta value 3,3.
Beta value 3,3.
Yes, sir. For the distribution fit.
Okay, you mean distribution beta 3,3.
Yes, sir. Yes, sir.
Okay,
So
then
how he calculated that, sir? It is not shown in the video. So I have tried to calculated it, but I'm not getting the answer.
do you know which question it is?
So first question, 11.10, first question.
Do you remember the slides?
Yes, sir.
Okay, this one.
One second, sir. Yes, sir.
Okay, so what your question here?
So bin counts of 100 samples from beta 3,3 distribution are given below.
Yes.
So this is given that CDF. I am calculating via PDF. So in this calculation, how we are calculating the how we are getting 25.9, sir? I am not getting it.
25.9. And others you have got.
No, sir. I have tried the first one, this
So
one,
for that you need to
2.420.
know the beta distribution, PDF CDF of the beta distribution,
Okay.
right? So it's not the beta distribution doesn't have the closed form.
So I
CDF
have
doesn't
just I am using the formula x to the power alpha minus 1 and 1 minus x to the power beta minus 1.
So this is the proportional 1 minus x is power beta minus 1. Some constant comes here. I think the constant is gamma alpha gamma beta upon gamma alpha plus beta. So
Yes, sir.
for finding this is the PDF, right?
Yes, sir.
So CDF, so you need to find probability of x lying between what is the 0.3 to 0.6, right? Whatever that is.
0.22, yes, sir.
0.2 to 0.4.
4.
Right? So this is your PDF. So what will be this? This gonna be your this constant, let's say k x raised to power alpha minus 1 minus x raised to power beta minus 1 dx from 0.2 to 0.4. Okay. So this integration doesn't have any closed form.
Yes, sir.
Okay, so but the beta distribution, the values you can calculate it using the packages scipy.stats. From there you can calculate those
So,
values.
but if we got this kind of question in the end term exam, so we are not able to.
Yeah, definitely
Can
we
we?
cannot do manually this kind of this kind of calculations because this integral doesn't have any closed form.
Okay.
Right? Because actually beta this is a function beta x. It is defined in a way 1 minus x raised to power x minus x raised to power something. That's it. No, not x. It is defined. Let's gamma alpha. So x raised to power alpha minus 1 minus x raised to power something like that. I don't remember exactly what that is.
So means we cannot calculate it
Yeah.
manually.
Yeah. So this because this integral doesn't have any closed form.
Okay.
Okay,
So,
that's
sir, can we do we have any type of questions like can we find any type of questions in the NTEM exam related
no,
to
no,
this
definitely
topic?
not, because you cannot do such calculations,
And
and
sir,
you
I
are not
have
allowed to use any packages or any other calculator, scientific calculator there.
yes, sir. So
So
I have seen 11.8 activity questions. You have showed in the discourse form also the answer of the first question.
11 point.
8. Question number 1, sir. You have also shared the answer on the discourse form,
Hmm.
but I am not getting it, sir. E to the power something. At the end, e to the power x bar n. Exp x bar n.
Let me see. This question you are talking about.
Yes, sir.
So how do you define
Hello,
the
sir.
like?
I had a question with respect to the first question. Actually, sir also did beta distribution questions, sir, in the lecture.
Which question you are talking about?
11.10.
11.10. First questions. First question.
Gamma.
Okay, what's your doubt?
No, sir. Sir actually explained that in the lecture for continuous distribution.
No.
Chi-square test for goodness of fit.
Yeah. So I didn't get your doubt. What's your doubt in this?
Sir, how did he calculate the values?
That's expected values or observed. Expected values are,
Expected, yeah.
yeah, expected values you have been given. Okay, because in this case you cannot do this kind of calculation manually. You need some kind of packages to find out those values. Sir has done using the if you have remember, Sir has done using the sci-fi.stats package. From there you can calculate those values. Because if you remember, gamma distribution again has a PDF for e raised power 1, e raised power minus alpha, that beta x raised to power alpha minus 1, right? Again, this integral is not easy to find out,
Sir,
because for
so
finding
such type
finding
of
this,
questions that goodness of fit for continuous random variable,
yeah.
they
So expected
won't
value
come in
will
the
be
exam,
given to
right?
you. No, no, it may come, but the expected value will be given to you. Okay, or some as such distribution will be given. For that you can calculate the PDF CDF values, right? For such kind of questions, you need to find out the expected values. That is not possible doing manually. Okay,
Okay, sir.
but
Yeah.
if it is uniform or some other distributions, then you can calculate. So that kind of question may come.
So I have a question in mock set 1.
So let me finish that question first. In week
Okay, okay.
11.8, 11.8, question number
Question
1.
number 1.
Yeah. So how do you define likelihood ratio test function?
So likelihood ratio test taking h naught
No,
on the
here only what is likelihood ratio function it is asking.
so e to the power so
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 likelihood,
we have to take only likelihood, right?
Likelihood ratio function. You need to find
Ratio.
likelihood ratio function.
So the likelihood
likelihood
for
when H
alternate,
naught is rejected by likelihood when H naught is accepted.
No, no. My question is, what is likelihood ratio function?
so it is the ratio of
ha
alternate
upon
likelihood
h naught.
upon
Uh,
the
uh,
null likelihood.
yes, sir.
One by one. I got confused what you said.
So likelihood of alternative upon likelihood of h naught.
Yeah,
Null.
likelihood when alternative is true.
Yes, sir.
Likelihood when null is
Alternative
true,
upon yes, sir. This
right?
one.
So
Yeah.
your H naught is defined as in this question. H naught defined as mu take value -1, and H a is defined as mu
Plus
takes
1.
value 1, right?
Yes, sir.
And your x that sample is coming from normal mu2. Okay. So
Yes, sir.
mu equal to -1, Ha is defined as mu equal to 1, and your samples are coming from the normal mu comma 2. Now, what will be the likelihood when H is true? H is true means that your X size following normal 1, comma 2, right?
Yes, sir.
When HA is true. Now, what will be your likelihood?
Likelihood e to the 1 by e to the power
Yeah. So that is gonna be
So
your
multiply
product of
PDF.
product of PDF values, right?
Product of PDF values.
Okay, I is equal to 1 to n, and so in this case it's gonna be 1 by root over 2 pi sigma, right?
Yes, sir.
To power n, and e raised to power minus, it's
Minus
gonna be summation, right? Xi
yes,
minus mu to
xi
the
minus
whole
whole
square
square
by
upon 2
2
sigma
sigma square. Okay,
sigma square.
and this is when okay, if I define likelihood ratio, so this is the likelihood when HA is true, and product of likelihood when
It's not is true.
it's not is true, right?
Yes, sir.
So in this case, let's say this is your sigma 1. Sigma is same in both the cases.
Yes, sir.
So remember, this term will be vanish, this term will vanish, right?
Yeah.
Because it is constant and will vanish from both the term, both the numerator and denominator. So now you will be left with exponential summation minus summation over x size minus, here in this case it is gonna be 1.
So we are neglecting sigma is it, because it is also a constant.
Yeah, because it will just it will be deleted for
Okay.
both the terms, right?
They will
It's
cancel out.
cancel out, right?
Okay.
Right. Now this thing here, when h is true, your mu is 1, so this will become summation over x size minus 1 raised to power 2 upon 2 sigma square, right?
Yes, sir.
Upon x size minus this gonna plus 1 upon
Plus
2
1
sigma square,
sigma square.
right? So
Yes, sir.
this is your likelihood ratio.
Yes, sir.
Now you just need to evaluate this and get your the exact term whatever has given to you in the form of that, right?
Yes, sir. So you have taken the minus out in the sir discourse form that you have used 1 by 2 and in the denominator 1 by 2 negative. So e to the power 1 by 2 upon e.
Up to this point you
Deno-
got, up to this point
sir,
you got
yes,
what?
sir. It is
Now,
clear.
what is this? This is just e exponential minus summation over 1 by 2 sigma square will be constant from both the terms, right?
Yes, sir.
Now, this is what? This is gonna be your minus summation over x size minus 1 to whole square, and this gonna be plus, right?
Yes, sir.
If you will open the square term, look at this. This is gonna be x size square and x size square, but this will come with the negative sign and this will come with the positive sign.
Positive sign.
So all will be cancelled, right?
Yes, sir.
Look at the constant term. Constant will be 1. Again, here will be 1, right? But this will come with the minus sign. So all those will be cancelled out.
Okay, sir.
Right? Now you will be left with 2 x size, right? With
Yes,
minus,
sir.
because if you will open the square term, you will get minus 2 x size, and minus minus will become plus, right?
So, but in the exi plus 1 to the whole square, we have to take 2 negative, right?
2 and negative is also already there. 1 negative is already there outside. That has become positive. Just okay. Just don't be confused. Do step by step. So it is your
So
xi
from where
square.
you have from where you have get the second term in the plus.
This is in the denominator, right? It goes
Yes,
and
sir.
becomes positive. It is just e raised to power e raised to power some term, e raised to power some term here. So what is this? It is e k plus t, right?
Okay. Yes, sir.
So here it is denominator, and the I'm pushing it in the numerator, so it will power exponent will become positive.
Yes,
Change of
now
sign.
now
That's
it is clear.
right. So you will get something like that, exponential x bar. Okay.
And so we have to do like same like this is in the second question as well.
Yeah, same.
Okay, sir.
Okay. So any other questions?
Sir, one question.
Yeah. Which assignment?
Sir, actually, it is in week 10 practice assignment.
Okay.
My question is not related to, it is a question there, but 8th question. My question is, sometimes we are calculating the variance using NPQ, and sometimes we are calculating variance in some question like PQ by N. Then
Okay, so I think you are getting confused within X bar and
where to use NPQ, where to use PQ
Okay.
by N.
okay. So I think you are getting confused within the two terminologies. Okay, so let me share first. Okay, so let's say your test statistic is T. I'm defining as x1 plus x2 plus up to xn. Okay, this is one way, and the second way I'm defining as, let's say this is T1, this is your T2. I'm defining as x1 plus x2 plus xn divided by n. Okay, so these are your two test statistics, two different test statistics. Okay.
Okay.
Now I'm saying that these xi's are coming from Bernoulli P.
Yeah.
Okay, so in this case, what gonna be your variance for T1?
It is PQ, P1 minus P.
What is the variance of xi? Any xi? PQ, right? T1 minus P.
Yeah.
mean. So what gonna be this variance of T? Variance of T1. They are all IID, that is independent.
Yeah, yeah.
So what gonna be variance of T1? It's just sum of individual variance.
Okay, okay. NPQ it is.
NPQ, right? NP1 minus P. So in this case, what is gonna be your variance?
Okay, it will become
P into
NPQ
1
upon
minus
N square.
Right? This thing, right?
Yeah.
N square will come out, and these are the summation of all individual variances.
Okay, okay.
Okay, so so I think you have confusion within these two terms. If your the test statistic is defined in this way, then your variance gonna be n p n minus p, and if you are taking
Yeah.
x bar, then your variance gonna be p n minus p by n. So be careful when choosing the test statistic. It can be either of these two, but what is the easy way to do, right? What is the acceptance region has been given to you? According to that, what is gonna be easy for you? Let's say some of the question you have been seeing that number of students saying no or yes, and saying that you have taken sample out of 100 students, and out of 10 students are saying you are defining acceptance region is like that. If the number of students saying yes is less than 10, then reject or something like that, right? So you are dealing with numbers there. So it's better to define test statistic as sum rather than sample mean. You can define the sample mean as well. Then in this case, you have to convert this acceptance or rejection region into that sample mean, because out of 100 you are saying 10 you will reject when the count is less than 10. Then actually your the test statistic value that you are getting from the sample gonna be what? 10 by 100, 0.1. But if you have taken t as x1 plus x10 or say xn, then in this case your acceptance or rejection region gonna be 10 exactly, whatever that sample test statistic value. So be careful what you are choosing as a test statistic. You can choose either of these two. Okay.
Okay, sir.
Sir, if you are done
Sir,
here,
I
have
had a
question
doubt
in
in
sir.
practice assignment
But he
11.
asked before.
Yeah, please, one by one.
Sir, I asked Mark question, sir. Could you go to Mark set 1?
Set one. Okay, mock, right? Mock 4 and come set 1.
Yes, sir, set 1.
Question number.
Sir, can you solve the first question?
Question number first.
Yes, sir.
How it is defined?
Sir, f is given as k plus 1 times k x raised to k.
Okay.
The So till the second last step, I'm getting as same as the solution. But the last step, I'm missing, either I'm missing something or the solution is wrong.
Right? Now your sample is your what is gonna be your likelihood function? Product of, right? So now your sample is taken as 0.6, 0.4, 0.9. 0.6, 0.4, 0.9, and 0.2, 0.5.
Yes, sir.
Now give me the likelihood function.
Sir, the likelihood function is sir k plus 1 raised to n.
Here plus 1 raised to power 5.
Yeah, x1, x2, xn till xn.
Product of all these, right?
Yes, sir.
What is this?
Sir, 1 minute.
Sir, not only the product 0.6 to the power k into 0.4 to the power k and so on.
Yeah. So product of all these 0.6 raised to power k, 0.4 raised to power k,
Sir, it's a 0.0216, sir.
0.0126
0216.
To the power k.
to raised to power k, right?
Yes, sir, right.
Okay. So this is your likelihood function. Now what you will do next? You will take the logarithm. So it's gonna be 5 ln k plus 1 plus k ln.
Sir, I have another question right here.
Okay.
When do we take log raised to base 10, log base 10 and log base e?
No, always take log base e, because if you remember that the dy dx of ln x is 1 by x simply, right?
Yeah.
But whenever you take dy dx of log base 10x, so some constant comes like 2.303x, something like that. Okay, so it is easy always to take logarithm base e.
So
Right?
even
To
in
avoid
example,
this
I will just
constant
assume all the log as a natural log.
as base e.
Okay, sir. Okay.
To avoid this constant, otherwise you have to take care of that constant as well.
Okay, sir.
Okay. So now next thing is you have to take logarithm and you need to find such k for which this function takes the maximum value.
Yes,
Right?
sir.
This is your procedure for finding this. So this is gonna be 5 upon ln k, 5 upon k plus 1. Right? I'm taking logarithm and I'm doing integration, differentiation and equating to 0. Then it is gonna be
Minus
minus
k by.
mn.
Yes, sir. Right.
Right? So
Sir, now the logarithm, I'm telling a log value.
no, don't take the log value. Okay, it's giving as a constant. Okay, so you have to take the log value. Okay, what is the log value?
Minus 3.8.
Whatever this is. Now this is your correct way. Whatever you will get, it's the correct answer. Until if you didn't make any mistake in calculation.
I think I've taken log base 10, sir. That's why I got it.
Yeah, because that's why you have to take care of that. Yeah, if you are taking log 10, then you have to take care of that constant. So
Okay.
take always log base e.
Sir, could you solve the last question also? Last question in the set 1.
This one, the question number 12.
Yes, sir. 13, sir. 13.
Yeah, so 12, 13 are the same. The random sample of 400 voters in a certain city are asked if they favor the hike in the fuel prices. Okay, so now tell me what is your null hypothesis and alternative hypothesis. So it is given null is p as 0.6 and alternative is p not equal to 0.6, right?
Yes, sir.
And
Sir, I have
acceptance
one
region is
question.
given as you will. Sorry.
Sir, should we keep the proportion as Bernoulli itself, or should we use it as binomial, sir?
So sum of Bernoulli you will get sum of Bernoulli, right?
Yeah.
So sum of Bernoulli is binomial. Ultimately, you have to approximate is using normal distribution.
So it doesn't matter what I keep as?
Yeah, so xi's are your Bernoulli P.
Okay.
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 So so sum of random variable you can think at as you can approximate as using normal distribution.
Okay, sir.
Okay. Now you can do this question, right?
Sir, no. Can you still do the 13th question?
Okay, so your acceptance region is what?
Acceptance is
Now what you will define as a test statistic?
X bar, sir.
Okay, x bar. If you define x bar, then what is gonna be your acceptance region and rejection region?
X bar minus 0.6 greater than rejection region. Talking about rejection region, X bar minus 0.
Give me any rejection region or acceptance region. So so you are defining T as your x bar.
Yeah.
Right?
So
So x bar means your x1 plus x2 up to xn divided by n, where n is coming from T, right? Right?
yeah.
Now, so acceptance region is given that whenever out of 400, or how many were there? 400, right? Out of 400, if the number of people who favors are in between 220 to 260, you will accept the null hypothesis, right?
Yeah.
So that is you are gonna accept whenever x1 plus xn is gonna be in between 220 to 260, right? So this is your acceptance region is given to you.
Yeah.
Right, so you have to change accordingly to this thing. So this is gonna be divided by 400. So you will accept whenever x bar is lying between this thing, 22 by 40 and 26 by 40. Now this is your acceptance region. Then
Okay.
any problem in this?
Nothing so far, sir.
Sorry.
Sir, no problem so far.
Okay, so now second, 13 question is saying find the probability of committing type second error, right? So what is type second error?
Sir,
Type 2 error.
beta is equal to probability of acceptance given that H alternative hypothesis is true.
Given alternative is true and you end up with accepting null hypothesis.
Yes.
Right. So accepting null hypothesis means this region, your x bar lying between 22 to 40, x bar 26 upon 40, given s naught is true. That is p is what? Given as 0.48. Right?
Yes, sir.
If the 40%, 48% voters favor the high, that is p is given to you 0.48. Now, if the p is 0.48, what is gonna be your expected value of x bar? What is the expected value of x bar?
Sir, 0.48.
0.48. And what is the variance of x bar?
Sir, 400 into 0.48 into 1 minus 0.48.
X bar.
Yeah.
What is the variance of x bar? Sigma square by n.
Yes, sir.
Sample mean. So what is the variance of sigma square? P 1 minus p.
Okay, okay, sir. Okay.
Right?
Yeah, okay.
So
Sir.
now you can convert this into the normal. So x bar minus 0.48 divided by root over this thing, whatever this is. Sigma, let's say sigma 1 square. Sigma 1 square. So whatever that 26 minus 48, 20.48 upon root over this thing. So now this has converted into z. Right?
Okay.
This probability you can easily find out using the table or using the this values will be given to you. Okay.
Okay, sir. Okay. Understood, sir. Thank you.
Yeah. So next question.
Sir, it is from practice assignment 11, last question.
Twelfth question.
Yes, sir.
Okay, so what is gonna be your null hypothesis here?
Null is that our variance is 0.5.
And what is alternative?
It is not equal to 0.5.
The company
Actually,
wants to
sir,
test
this
the
also I had a
variance.
doubt how to predict that the alternative will be not equal to here.
Yeah, exactly. Because in this question, nowhere mentioned that you need to take not equal to 0.5. The only thing that is given to you is that company wants to test the variance, right?
Yes,
So
yes.
can we conclude that they want to test whether it is 0.5 or not 0.5? Does it mean that?
Actually, I interpreted it that way.
Yeah. So it needs to be clear, more clear, right?
Yeah, yeah. Actually,
The company wants to test
and
the variance, so I
nothing
think
is mentioned like they are suspecting it to be low
greater
or
than or
high.
lower, or
Yeah.
whether they are testing variance means, I think it means only that whether they are checking whether the variance is 0.5 or not 0.5, right?
Yes,
So
sir.
let's do in that way. So your variance is 0. Sure, your null will be sigma square gonna be 0.5 and the alternative gonna be
Not equal to 0.5.
0.5. Okay. So now what gonna be your test statistic?
Sir, S square.
S square. Okay. And do you know the distribution of S square? Any other constant you just multiply and then find out the distribution of S square? Do you know
Yes,
anything
sir.
about
We
that?
can do the chi-square test.
Okay.
But sir, I didn't understand how they are taking both the sides, and can
Yeah.
you
So
do
okay.
this? Yeah.
So
Thank you, sir.
your alternative is gonna be sigma square equal to 0.5. Sorry, null, and alternative is gonna be sigma square is not equal to 0.5, right? So your x square, your test statistic gonna be x square, and I know that n minus 1 x square upon sigma square, so chi-square distribution with n minus 1 degree of freedom. Okay. So chi-square looks something like that. Peak, well, depending upon n. Okay. So
Sir, so F and chi-square are similar in
not similar. The
shape.
shape you can say somewhat similar. Exactly, right?
Okay, okay.
Okay. So now your test is gonna be what?
I had doubt in this only, how to go ahead with the test.
Okay, so you have to choose both sides separately. So you will accept whenever s square is greater than some constant. Let's say this is 1 minus cr or some constant. Let's say most of you have got confused between 1 minus cr and 1 minus cr. So let's say this constant is t1 and this is t2. Okay, so you are saying you will reject whenever the sample variance comes greater than t2 or s square is come less than this is t1 and this is t2,
Okay.
right? So now this is your rejection region, right? So this rejection region should be, probability of this region should be what?
Alpha
Alpha, rejecting,
0.05.
right? So for one region you can divide equally into two parts. So this probability gonna be alpha by 2 and this gonna be alpha by 2. So it means that
But sir,
probability
it
of
is not symmetric, right? How can we do that?
so that's why it's not symmetric. That's why I'm dividing equally to both sides. I'm dividing this area to be 0. Let's say my alpha I'm choosing 0.05. So I'm dividing this area to be 0.025 and this area to be 0.025 equally both sides. Right. Now this critical value come different. Not just because we are doing computations separately, just because it is not the symmetric. If it is symmetric, then I can do in the single term. But here you have to divide, you have to find this probability and this probability separately. So you have to
Okay.
find out this T2. I'm got confused. This is T1 and this is T2. So this is 0.025 and this is gonna be your 0.025. Okay, from there you can find T1 and T2 and check the values of S square. If any of these comes true, then you're gonna be reject. right?
Okay, so both need not be true. If
Both
only one.
simultaneously cannot be true, right? Both
Ah,
simultaneously cannot be true. Only one gonna be true. So if it any of these equality holds, then you're gonna reject.
okay.
You can find this T1, T2, right?
Yes, yes. Actually, in the solution, some other method was given, like it lies in the rejection region.
So what is asked there? Okay, yeah. Test the hypothesis that sigma is okay. Yeah, same thing. Finding rejection region, acceptance region, the same kind of thing. So you have to calculate it H square as well here. So lengthy calculation. Have you done this? Hello.
The sample standard deviation calculation.
Yeah.
Wait, sir, I'll check.
So it will be given to you in the exams. If such kind of calculations needs to be done, then it will be given. Okay, so it's lengthy calculation because you have to find x bar, then taking taking the mod, no, that deviation, taking the deviation, square it, and then divide it by those number n minus 1. So it's a lengthy calculation here. So any other doubts in this question or any other question?
Yes, sir. Actually, I had doubt in this and two failed F test only.
Okay,
So
so now it should be clear, right?
yeah, it's clear. F test is also similar, right?
Yeah, same thing.
So we check for alpha by 2 and
Yeah,
equate.
alpha by 2. Both sides you just equally divide the rejection region, alpha by 2, alpha by 2.
Okay. Thank you, sir.
Okay, tell me one more thing. In F test you define as S1 square upon S2 square as the distribution as I have distribution with degree of freedom N1 and comma N2, right?
Sir, we are not able to see your screen.
Okay, this way you define your distribution, right? S1
Yes.
square upon S2 square as follows. I have distribution with degree of freedom N1 comma N2. Now if I ask, your alternative is sigma 1 square is equal to sigma 2 square, and alternative is S1 square not equal to sigma 2 square. Okay. Now, can you find the type 2, a probability of type 2 error? How you will find the probability of type 2 error? Anyone? Give it a try. Just go step by step. What is the type 2 error?
Reject H naught when sorry, accept H naught when alternative is true. Accept
H naught.
uh, accept HA.
No, accept H naught when HA is true,
Yes, sir.
right?
Yeah.
Okay. So let's say your acceptance region or rejection region is you're gonna reject when S1 square is greater than E1 square and or S square or S square is less than T2 square. Okay, so this is your rejection region, right? No. This is not your rejection region. Rejection region is defined as S1 square upon S2 square is less than or equal to 1 minus CL or say some constant T1 or S1 square upon S2 square is greater than or equal to T2, right?
Sir, do they have equality signs there? I think it is strictly less than and strictly
No,
greater
you
than.
can avoid. This is gonna be a continuous random variable. So don't worry about such equality here in this case. Okay.
Okay.
Don't worry about such equalities or inequalities because it's gonna be a rejection. It's gonna be a continuous random variables. Okay. Now my question is, can you find this probability? Okay, accept H naught means that your probability gonna be S1 square upon S2 square is lying in between
In between T1 and T2.
T2. When H1 is true. Now what next? How will you find this probability? How you will find this probability? Anyone? Am I audible?
Yes, sir.
Fz of T2 minus Fz of T1.
It's a F test.
Z. This doesn't follow Z. This is not Z. Is it Z?
No, F test only, but we can do the CDF computation, right?
How you will do CDF computation? You mean f of T2 minus f of T1? Is it?
Yes, sir.
Yes, sir.
This is not true because remember S1 square upon S2 square follows F distribution with degree of freedom n1 comma n2 only when sigma 1 square is equal to sigma 2 square. Okay, this is true only when
okay.
this happens. Actually, what is this? This is S1 square upon sigma 1 square upon S2 square upon sigma 2 square follows F distribution with degree of freedom n1 comma n2. Okay. So sigma 1 square sigma 2 becomes equal, so this will be cancelled out and it means that S1 square upon S2 square follows F distribution. So in this case, since I'm saying H1 is true, H1 says that your sigma 1 square and sigma 2 square is not equal. So in this case, you cannot say that this follows F distribution.
So can we convert it into a standard normal?
How you will convert into standard normal?
Like CLT or something?
How you will apply CLT?
I don't know the mu, but yeah.
No, CLT applies only when
But
CLT.
sir, S1 square by S2 square will turn out to be a constant. So
No, constant is okay. I'm saying this is a random variable. From the samples, you will calculate those values. That test statistic value is a constant. Always is a constant from that observed sample. Once you have observed the sample, the value of test statistic is always gonna be constant. But I'm doing the test, and this is my random variable. I'm interested in finding the distribution of this random variable. Right, and I'm saying I say that S1 square upon S2 square follows F distribution with degree of freedom n1 comma n2. This is true when sigma 1 equal to sigma 2. Okay, this is not true in general. So that's why I'm saying in this case, whenever H A is true and H says that sigma 1 square is not equal to sigma 2 square, in this case you cannot say that this follows where has that gone? This follows, this need not to be F. Okay.
sir, so how to go ahead with this problem?
Yeah, then you can that's why I'm saying you can do that S1 square upon if the alternative values have been given to you, let's say sigma 1 and sigma 2, then you can proceed in that way. Okay, but there is some other way to do such calculation. This is beyond this course, so we will avoid doing those things. Okay, my just point just to remember this null distribution S1 square upon S2 square follows F distribution. This is true only when sigma 1 square is equal to sigma 2 square. Okay, remember this thing.
Sir, we can do this if sigma 1 and sigma 2 square are given,
Yeah,
then we can
you
get
can do the computation.
yeah.
Okay.
And sir, how do we calculate p-values for F-test? Like,
Yeah, so the p-value. Okay, so what do you understand by p-value?
it's like when the test statistic equals the critical value, the probability ahead or behind of
Okay,
it.
so let's say your test is you are gonna do test on what, mean or what? Let's say let's do
So
on.
I can't see your screen.
Okay, so So let's do some test. First do on Z test. Okay. Then we will go for other. Z test means your mu is equal to mu naught and HA is, you have three ways to define HA. One is this, right?
Sir, the situation will be given clearly in the question, right? Just
Yeah,
now we
situation
saw
will be
that.
given to you. Yeah, situation will be given to you.
Okay, okay.
So what do you understand by P value? I'm asking that.
So, sir, if you if you take the null hypothesis and you put the critical value as the test statistic we observe, the
Hmm?
probability that we will get, like, if it is a double tail, two-tail test, from ahead the critical value or behind the critical value. If it is a one-tail test, like above that critical value or below that critical value, like the area we will get, that is the p value, right?
Okay. So P value is the minimum significance level at which you reject your null hypothesis, right? Minimum significance level alpha at which you reject the null hypothesis as known, right? So this
Yeah.
is P value. So just think about the test statistic T. T is gonna be X bar, so you can approximate T as the normal with some parameter mu hat and mu and mu, let's say mu naught and sigma naught square, right? You can approximate it using normal. So let's say this is your Z. You can always convert this into Z. So once you have converted into Z, hello, hello. You are not audible. Is breaking from my side or it's
No, sir.
from your side?
From Pras side.
Okay, so I'm saying that you can approximate T using Z distributions. Now you have the Z distribution. So your rejection, in this case, let's say mu not equal to mu naught. So you are saying that you will reject your null hypothesis whenever your test statistics lie in this region, whether less than this or greater than this, right?
Yeah.
Okay, so you are interested in finding such critical value at which you gonna for which you are saying if it is lying greater than this C, you will reject, or lying less than this C, then you're gonna reject your null hypothesis. You are interested in finding such C. Okay, once I have observed my value of test statistic T, what will be your minimum rejection reason? Let's say you have observed such T here. So what is your gonna be minimum rejection region? You will reject when this T will come into the rejection region, and rejection region in what? Whether the T lies in the rejection region. So you are interested in such minimum region in which this T lie, minimum rejection region. So if I do this area, this is gonna be your minimum region, right? Because if you find such region, then this is not minimum significance level, right? So that's why I'm interested in finding the probability of X bar minus mu less than or equal to T. This probability will give you the P value, right?
Yeah.
Sir, is it the general rule that if p value is less than alpha, then we reject h naught, otherwise we accept?
Yeah, so go for the P definition of P value. P value says that it is the minimum significance level at which you reject. Right? It is the minimum alpha at which you reject. So what do you understand by this statement? What if I take alpha greater than P value? Then what will happen?
You will accept.
If I alpha take greater than P value,
Reject, right?
Reject.
Right? Since this is the minimum significance level at which you reject. If alpha is I am taking less than P value, then I gonna accept. Okay, you can check this using diagram as well, because I'm saying that let's say this is your T and test statistic value, and this is your normal 0 1. It's a 0 1. Okay, so this is your observed p value t. Now what you are saying, this is your alpha p value, this is your p value. Okay, so if I take alpha greater than p value, p value means that it is, this is area, this area is your p value. Now if I take greater area, so your area will be something like that, get bigger area. So t has come into the rejection region now, right? If I choose alpha less than p value, that is you are choosing lesser area. So now your t value has come into the acceptance region. You can always remember this picture in your head, so it will be easy, no confusion will be there.
So, sir, how do you do it for a like 2 sample lift test?
Yeah, just a minute. Okay, just a minute.
Okay, sure.
Yeah. So your question was what? When to
How?
do, when chi-square test or F test?
No, just the F test.
Yeah, F test. So F test is that your F test gonna be something like that, right?
Yeah.
Okay. So your hypothesis is sigma 1 square is equal to sigma 2 square, and sigma 1 square is greater than sigma 2 square. We will come to the next part later. Just think about this. This is your alternative. Now your test statistic is gonna be your s1 square upon x2 square, and your rejection region gonna be you're gonna reject when s1 square upon s2 square is greater than 1 plus right, greater than 1 plus CR.
Yeah.
So it means that this region you are talking about, right? So you have observed, let's say you have observed value of test statistic as t, small t. Now p value will be what? P value will be just probability of s1 square upon s2 square is greater than that t. That's it. Any doubt?
Can you elaborate that part a little? S1 square upon S2 square is greater than or equal to little t.
So this is your rejection region, right?
Yeah.
I'm saying that p value is the minimum alpha at which you reject, and when you reject, when this is true, right?
Oh, okay.
And
Yeah.
let's say this is your such t, test statistic. Now I will reject whenever my this t lies into the rejection region, and I will I want this region to be minimum. Then I just draw this line and say this is my rejection region. Now this is my such minimum rejection region.
Okay. So
I
I
cannot
would.
draw any minimum region for which this t comes into the rejection region, because if I draw any minimum region for that, then this t comes into the acceptance region.
Yeah, got it. So we would have to calculate the F distribution
This
value of t.
probabilities, right?
Okay,
Now,
thank you.
what about whenever s1 square is s2 sigma 1 square upon sigma 2 square, and alternative is defined as s1 square is not equal to sigma 1 square not equal to sigma 2 square. Then in this case, what is your rejection reason?
There would be like 2 limits, right?
So this is gonna be less than or equal to 1 minus CL, or s1 square upon s2 square is greater than 1 plus
1
CL,
plus
right?
CR.
So now you have observed the t value, test statistic value as t, small t. Now what is gonna be your p value?
So we can like evaluate those two CTFs and subtract them. No. Oh,
Actually, what goes wrong here? Look, this is not symmetric diagram. in the symmetric z value z distribution, what we usually do, we just say that if this is c, this is minus c, and this say we will say this is your rejection region, right? Whenever we are doing test of mu1 not equal to some mu naught, right? Mu not equal to mu naught. So finding rejection
Yeah.
region, you can take the similar rejection region both tails, because the area is similar. So you can say this is c, then this is minus c. But what goes wrong in this case, if this is t, then you cannot say this is minus t, right?
Yeah. Yeah.
So this tail you never know in this case. And you also we know that if your alternative in defined in this way, your rejection region will be in the both tails, right tail also, left tail also, right? But you never know what is this critical value in this case. Now this one tail you always know, what about the second tail? So in this is such kind of questions, it's not easy finding p value. Okay, but what if the one-sided test, if it is one-sided test or this thing, then you can easily find out the p value. Got it?
Yeah, sir, got it. So there are ways to find
Yeah.
this, or like there are no ways to.
Only problem is that we never know about the other tail. Only one tail we are sure. Right?
Yeah, thank you.
Okay. Can we how you will proceed from for finding such p value from here?
Take more samples.
Just think about this. What we generally do, we just take the twice of that, right? We do just one-sided tail. We just find one-sided area and just do twice of that, right?
Yeah,
In
so
case of
maybe for
in case of
like for F test, maybe we can find like there we take twice. So
okay,
it's
so
like,
all, yeah, it's just the twice of one-sided tail. Just because we are always finding the same area, whatever area here it is, we are just doing the same area here also, right?
yeah.
So let's say this area is 0.05. So your p value is gonna be 0.1. Okay, so it's not direct that you cannot directly find p s1 square is less than s square is less than p, or p s1 square upon s2. So my point is that don't go in such way that if it is t, then it is minus t. In the case of the mu, we generally do p value is minus c to c, right? It means x z less than minus c plus t z greater than c equally, right? But in this case, in when in the test f test, it's not like if it is t, it is minus t. So you just find one-sided area and just do the twice.
In F test too.
Yeah, f test or chi-square test.
So then like if we do it twice, doesn't that mean like they're not equal? So
No, doing twice means that what actually you have found it. You have found it. Let's say this is your t, and t s1 square upon s2 square is greater than or equal to t. You have found it this area, and I'm always interested in the same area for both the tails.
oh, acha.
Okay.
Okay, yeah.
So if your concepts are clear, then you won't be confused within what we are doing for finding p-value, what we are doing for alpha, finding alpha, and what we are doing. If you are confused within this concept, then it's gonna be problem. So be clear about what actually these are. What is the p-value? What do you understand by significance level? What is type 1 error, type 2 error? What is your hypothesis? What is the null hypothesis? Null distribution. Okay, means null distribution means the distribution of test statistic. This is also called null distributions. Okay.
No, actually the p-value is clear visually, but when you like try to explain, when I try to explain it in words, it's like it's kind of that way it is confusing.
Just do by yourself. It will be easy to think. Just think about the definition of p-value, what it means. It will be clear. Okay, just picture all these things. In the p-value is nothing but the area, tail area, right?
Yeah.
Because the probability is what? The area under the PDF curves. And in this case, our PDFs, we will just transform into the Z distribution or F distribution or chi-square distribution, something like that. So this is p-value is gonna be your area under those PDF values. So if
Yeah.
just think, if you are getting alpha greater than p-value, then you are increasing the area, tail area. And if you are lowering the p alpha value, then the p-value, then you are actually decreasing the tails area. So if you are decreasing tails area, that is your sample values shifted to the acceptance regions. If you are increasing the area of the region, tail area you are increasing, then your p values shifted to the rejection region, right?
Yeah, sir. Yeah.
So just think about those definitions.
Yeah. Also, sir, there's like this score updation in our dashboard. It shows like week to activity 0%, or like these new updates have come. What do they mean?
Score has been evaluated up to week 2, extra activity week 2.
Sir, but there was no extra activity in week 2, right? It was
No, you have extra activities, 6 extra activities, 6 or 7.
6, I think.
So yours up to second activity you have been that score has been evaluated.
Yeah, but it shows like week 1 activity 100%, week 2 activity 0, and week 3 activity 100%. So it's kind of weird.
So I am not sure about the extra activities, how it is given. So the only information I have is that up to week 2 extra activities, the score has been finalized.
Okay, I'll mail the support.
Okay, mail the support and with your that Google site. Okay, if you are writing on the that discourse or any support, then give your that student site as well.
Okay, sure.
Okay.
Actually, I can see week 3 activity as well, but there was no such activity.
Does it show like 0% for you too in the week 2?
So if you think you didn't get
Not for
0%,
me.
if you think your marks should be higher, then you can write to the support, or if you're writing on the discourse, please post your student site as well. Okay. Sometimes what happens, your sites are not accessible to us. In that case, we are providing 0 marks. Or we are not able to find your spreadsheet, or you are not Google Doc, whatever you have done, we are not able to access those files. In those cases also, you will got 0 marks.
Actually, sir, I've got like almost 100 in every activity. Then also I don't know why like it's showing 0% in the week 2 activity. So
Maybe the case it is not accessible. Your the sites your the spreadsheet or your Google Doc files are not accessible to us.
Sir, do you evaluate all these activities?
Not all. If some that you not got correct marks, then in those cases we do by ourselves. Okay. In the most of the case, your
Otherwise, what
peers will
the
do
peers
the
will give,
evaluations.
that
Yeah,
is
that is
only
the final.
okay.
Okay, so better to ask questions regarding concept and all, because it's the last live session. One more session will be on the mock session, where we will discuss only the mock questions, because there are 2 sets, so it will take time to solve those questions. So it's really better if you take your doubts here, whatever doubts are you have in the week 10, week 9, or week 11.
Sir, can you give a summary of the function of continuous random variable and joint density?
Week 3, you mean? Week 1, week 2.
4 and 5.
Function of continuous random variable.
Yes.
Okay, just give me a minute. I just come back in 2 minutes. Okay.
Okay, sir.
Yeah. So you were asking for from week 5. Describe what function of random variables, right? So I will recommend you only focus on week 8, 9, 10, and 11, because most of the questions will come from those weeks, week 8, 9, 10, and 11. 8, 9, 10, and 11.
7 also, or from 8?
From 8, 9, 8, 9, 10, and 11. Some part will come from 7, but most of the part will be from week 8 to week 11. Okay.
Okay, sir.
Yeah. So your doubt was in, what was your doubt? Function of continuous random variable.
Yes,
Who
sir.
asked that question?
Yes, sir.
So what's your doubt there?
Sir, could you provide a summary sort of thing?
So let's say x is your full continuous random variable. Okay. So x follows some distribution f of x. This is your PDF. Okay. You have been given PDF or you have been given CDF, doesn't matter, because you always can convert within these two. Right. Now you need to find the distribution of g of x. G of x means you have some function of random variable x, and now you need to find the distribution of y. Right. This is your question. So one way to find is that always
Yes, sir. Actually, there was some question. Actually, I had asked it before that quiz too, as well. That maximum and continuous mixture type of question.
maximum and
Maximum, this concept, and continuous random variable, this concept.
I didn't get your point.
It was
Please.
there in the tutorials, I guess. Can you do that question?
Which question you are talking about? Can you give me the question?
Yes, sir. I'll search for it.
Hello, sir.
Yes.
Sir, I have few doubts in the week 9 solution in the tutorial. So,
Okay. What's your question? What's your doubts?
sir, week 9 tutorial 2, question number 6. And there is another doubt in question number 2. It's in the solution. You can just bring the solution up front and I can show you the doubt I have.
Question number 2.
Yes.
Okay. Okay.
Sir,
What's your doubt?
here the probability, the prior is uniform 0, 4/6, right?
Hmm.
So in the prior, I have to write 1 by
Yeah.
0.66, right?
This is wrong. This is not 0.6. It is gonna be
Yes.
1 by, right?
So that's one of my doubt. And
Yeah. This
question
is
number,
wrong. This is not 0.6. This is gonna be 1 by 0.66. So it's a constant. So just answer
yeah, I know,
is not
yeah,
different. Answer will be same.
I know that. So that's because there was a fuss in my mind because,
Yeah.
okay. And sir, question number 6, sir, I couldn't understand the solution at par with the question that they have asked.
Question number 6.
Yes, sir.
What didn't
Sir,
you
the
get?
likelihood function.
Where it's likely function? P raised to power n minus 1 minus raised to power
Yes,
p,
yes,
is it?
sir. Yes. If you once again go through the question and try to interpret it in the whiteboard, I'd be really grateful.
Okay, so what distribution it is? I'm saying X is a geometric P. Isn't it geometric? He decides that as soon as he finds the person who is not vaccinated, he stops survey, or he'll end the survey, right? So what distribution it is? The geometric distribution. Hello.
Hello. So can you hear me now?
Yeah.
Yeah. So it's a geometric distribution with a prior beta. So I get that. So,
Yeah.
so see, it's written P is the probability, is the proportion person who is vaccinated, who is not vaccinated.
Yeah.
So, so I think I'm not interpreting the question rightly. So if you can just write it down in a whiteboard, so what to expect, because I can't find while I was trying to do the solution.
With an expected value of 0.6, the fifth person is surveyed is found to be vaccinated.
The
Okay,
fifth person
he
is
has
surveyed
given
is found not to be vaccinated, right?
found
Not to be vaccinated.
not found to be not vaccinated. So your this is your one sample, and your what will be your likelihood in this case?
So it's the likelihood will be,
P raised to power 4
yeah, right. P, oh,
and P. You have only one sample.
as I said, there is this interpretation because the sample must, matlab, the sampling must go on until he find that person who is vaccinated. So
Yeah.
how can I stop there at number 5? Because he must go on. So shouldn't the idea of the sample being 5, that's causing a problem in my head.
No, actually, he takes only one sample in this question. In one sample means that he stops when he got vaccine. He found the person is not vaccinated, right? And in the one sample, he found that the fifth person is the one who didn't get vaccinated.
Okay.
Okay, so this is your one sample. He took only one sample in this case.
So how do you get that? Means that is what my conflict lies, because
How
means
did you get what?
the sample of 5, n equals to 5, because for a sample, to have a sample you have to stop, right? But
Yeah.
he starts the survey and he will not stop until he finds someone who is vaccinated. So if he does not stop, so where does the sample count comes from?
No, but in this case, in this question, it is given the fifth person he surveyed is found to be not vaccinated.
Okay, so therefore he must continue, right? He must go to the 6th and 7th and 8th, because the fifth person is still not vaccinated and he must pursue until the point he finds the one who is vaccinated.
No, he decides that as soon as he finds the first person who is not vaccinated, he will end the survey.
Yes, that is the problem.
Yeah.
That's what I'm facing difficulty in
So,
understanding.
so in the
So P to the power 4.
So in this question, read the last line. It is saying that the fifth person he surveyed is found not to be vaccinated.
Okay.
Then he will stop the survey, right? He decided that as soon as he finds the first person who is not vaccinated, he will end the survey.
Okay.
And in this sample, he found that the fifth person is not vaccinated. So he will end the survey now. So this is your one sample. Okay, and he collected only one sample in this case. If you are collecting the second sample, then you will start again the sampling.
Okay,
and
so
if
then
you
it will be P to the power 4, 1 minus P, right?
yeah,
So actually,
right.
actually, I was, the PDF of geometric is 1 minus P to the power n minus 1 into P. So actually, I think there was a, I was doing wrong there also, maybe. Thank you, sir.
Sir, that question was week 4, tutorial 2, last question.
Okay, that question we have already discussed, right? Or we didn't?
Sir, will such type of questions come in the exam?
It may come. Yeah, I have. It's not like it cannot come. So y is defined as maximum of 4 comma minimum of 8x, 4 comma 8x.
Sir, there's 4.
4 comma. and x follows uniform 0, 20. Could you please mute yourself? Now you need to find the distribution of y. So how you will find this? Okay, you just convert this into the nice form. Y gonna be what? Y gonna be your maximum of this thing. So minimum 8 comma x. Okay, so whenever x is lying between, so let's say whenever x is lying between greater than 8, right? So in this case, what gonna be minimum of 8 comma x itself? Sorry, 8, right?
8.
And whenever x is less than 8 and greater 0 to 4 to x, so in this case what is gonna be minimum of 8 comma x, right? X, right?
Sir, for x greater than 8, I understood.
Now I'm saying that y gonna be your whenever x is greater than 8, it is gonna be your maximum of
8. Yeah.
4 comma 8, right?
Yeah.
And whenever x is less than 8, what is gonna be minimum of 8 comma x?
X.
X, right? Now this is 8, right? So now whenever x is less than 4, x is greater than 4, what is the maximum of this thing? Whenever x is greater than 4,
X.
what is maximum of 4 and x? X, right? So whenever x is greater than 4, your y will take x, and whenever x is less than 4, what is
It
this?
will be 4.
4. Right? So this is your y. Now you need to find the distribution of y, and x is given to you uniform 0, 20. How you will find this? What is the way? You cannot do direct formula. You cannot apply direct formula because it's not the it's not differentiable function, right?
Yes, sir.
So you cannot apply the formula here. So you need to find CDF of y. What
CDF.
is,
Yeah.
okay? First, give me what is the support of y?
0 to 20.
Support of x is 0 to 20. What is support of y?
So 4 to 8.
4 to 8. Look at the values. It takes 4. It takes value
Yeah,
8
4 to 8.
and
Yeah.
between 4 to 8. So it is 4 to 8. Now, how you will find the CDF of y? CDF of y will be defined as, let's say, f of y is the CDF of y. So it means that probability that y is less than or equal to y, right?
Yes, sir.
So whenever, let's say, y can be your within 4 to 8. This is your support, right? So look at the that function of y function y. It is changing behavior for at 4 at 8 at right. So check these values. What is probability of y less than or equal to 4? What is this
4
probability?
plus x.
Y of 4.
When y takes value less than or equal to 4. Whenever x takes value less than or equal to 4. Right? And what is this probability? X follows uniform 0, 20. Now what if y takes value between 4 to 8? What will be your p by less than or equal to y? It is the same as probability that your x will lie between, isn't it? So what is this probability? sorry, not 8 into 8. This is same as by and 4, right?
Y minus 4 by 20. Y minus 4 by 20.
Am I doing something wrong here?
No, sir.
So what is your answer?
So second one.
Not second one. Something wrong I'm doing there. When y is in between 4 to 8, okay, plus 4 by 20 or will come again. So this is gonna be a by 20. So it is same thing. The same thing you can write as by whenever y is less than 8.
Sir, is it the previous 4 by 20 you are adding?
Yeah, this by
Okay.
less than 4, right? This 4 by 20 I'm also adding. So this will same as so this will become by 20 whenever this, and whenever y is greater than 8, it is takes 1. So can you think this is a continuous random variable or not? This is not continuous. Look at this here. It is a gap here in this case. At 8, it is 8 by 20, and it takes the jump at 8. It becomes 1, right? So it is something like that. It is 0, and then up to here at 8, it takes the jump. So it's not continuous.
Yes, sir.
Okay, so it's kind of mixed distribution, not discrete, not continuous. So that was the confusion. I was thinking like why f of 8 is not coming as 1. But just because it's not a continuous random variable, so f 8 it is defined as 1, not 8 by 20. Okay.
Okay, sir.
Any other doubt?
So one conceptual doubt.
Which doubt?
So when we are taking null hypothesis and alternative hypothesis, so which is better?
Which is better means what?
Like when we are rejecting null hypothesis or accepting null hypothesis, which one is better? So it is like if we are taking an example, there is a mean and we have a doubt that mean is lower than some other constant or something.
Okay.
So I know the concepts clearly, but I don't know why we are taking like why we are considering this. So null hypothesis is better, so alternative is better. So because we are taking some samples also
Yeah.
to yeah.
So what do you
Get
mean by better? being better. What do you mean by
So
which one
there
is
are
better?
some questions in the examples also, activity questions 11.6 or something. And it is asking for the fit that this type of distribution is given, and it is yes or no in that kind of answer. So the fifth one.
This one?
Yes, sir. Sorry, seventh, sir. Yes, sir. Are the data significant enough at the 5% level to prove that the change has
Okay,
occurred?
so I think your doubt is so here you need to conclude whether you are rejecting null or whether you are accepting null, right?
Yes, sir.
So once you have reached the conclusion, let's say you have reached the conclusion that you have rejecting null. Okay.
Yes, sir.
And what your null hypothesis says that your mean is 2000.
Yes, sir.
Okay. And what the question says?
Question says it is less than that alternative
Are the data
hypothesis.
significant enough to prove that the change has occurred? Change has occurred means that mu. What is your answer of 6? So change in this question, the change means that your mean is less than 2000, right? And if you are accepting the null, it means that you are accepting null means that no change has occurred.
Yes, sir. I know that the no change has occurred. I have calculated the given mean. Also, sorry, the C also, that is 1919 point something.
Yes.
So just I am asking for the same, like why we are calculating null and alternative hypothesis. Sorry.
So what do you understand by null hypothesis and alternative hypothesis?
The null hypothesis that is already given, and the alternative hypothesis that is we have taken some type of examples from the population.
Yes,
Like
your
sample.
assumptions about that.
Yeah.
You feel that whatever is true is not actually true. For making your conclusion true, or you claiming whatever you have claimed to prove that, you just do the sampling and do some analysis on that, right?
Okay.
Okay, so null hypothesis is one which is supposed to be true, which is by default is true.
Okay, by default is that is null hypothesis which is
Is
true.
true, but
Okay.
you have some suspicions about that. Let's say
So when we reject the null hypothesis, that means our assumption is, so the default is wrong.
No, I'm for making the conclusion whatever you are claiming. For proof your claim, what you will do, you will collect some sample from that distribution. For let's say some example. Let's say I believe that the class performance will be that average of class will be 60. This is my claim. This is my let's say null hypothesis that the average will be 60. But
Okay,
you
sir.
Sir, I
suspect,
always thought that null comes from some previous experience.
your previous experience, whatever is true, whatever distribution is true, right? What is by default is
The
true.
null comes from the distribution, right?
Null comes from the distribution is what?
So the distribution, like if I am taking a normal distribution, and after
Because
that
sir,
I am
always
calculating from the samples.
when they are
That
defining the null, they are saying that mean some weight is 60 kilos or something. They are already giving that information.
Yeah, giving them information, but someone can suspect that it is not 60. My claim is that if someone has claimed that the total vaccination is 60%. Up to now, total vaccinations is 60%. Now I'm claiming that it is not 60%, it is greater than 60%. Okay, so I'm claiming that I have to prove my claim. I cannot just say that it is greater than 60. I have to prove that, right?
so for that we
Just
use
saying that
significance level.
yeah, for prove my claim, what I will do, I will collect some sample. from that sample I will do the analysis, right?
Right, sir.
So for that we will we will find the rejection region and acceptance region on the basis of the error. You might make the errors, right?
Yes,
So
sir.
two types of your error be defined: first type and second type. First type error, probability of first type error, you define as the significance level, right? And the second type error, probability. So you
Power.
want these two both to be
So
lesser.
second is power.
Second is not power,
Sorry, second is not power. That is the
right? So proving your claim, you have to make such you have to collect some sample and you have to do analysis on that, right? It's not like that you just say that it is not 60, it is just greater than 60. So you have to make you have to prove that. And for proving what is your weight, just collect the sample. Just a things simple thing. You are saying that the actual weight of this let's say salt packages, whatever you bought, it's not 1 kg, it is greater than 1 kg. For proving that, what you will do, you will just collect the samples, right? You will collect the different packages and will check the weights. If you found that it is 1 kg, 1 kg, 1.2 kg, something like that, is coming in some range 0.8 to 1 kg everywhere every time, then you will say that it's a 1 kg. But if you suspect that and if you have collected some samples of 100 packages and you found that the average weight of all such is greater than 1.5, then you will claim, right, that it's not 1, it is greater than 1, right? Because you have collected some sample and you have shown through the sample that it's not 1, it's greater than 1, right?
yes,
This
sir.
is the way you just collect the sample and do the analysis on that.
So we use the like the simple these concepts in a future of like future courses also.
Yeah, in machine learning you may use all these things.
Okay.
Okay.
Okay. Thank you, sir.
So any other doubt? Did you attend the session that Antusa took the last Monday, I think, Monday or Sunday, Monday. So sir has taken some examples, real life example on that, right? So it will make clear things, why we take sample and how do we do analysis on that.
Yes, sir.
If you haven't attended this session, just go through the YouTube link once.
Okay, sir.
So you don't have any more doubts? If you don't have any doubts, we can close the session. Okay, so I think we should close the session now. No one has doubts.